Good morning and welcome to GIS 300 week number 3. This week's data we have two data layers, NAPE 2015, National Agriculture Imagery Program 2015 data, and we have GPS color data from deer number 19. Deer number 19 is a female deer. Her tracking began on March 18, 2013 and ended March 29, 2015. Therefore, this air photo shows the landscape as close as possible to how she experienced it, excluding, of course, the seasons. Now I want you to bring this data layer in twice, so just double-click again, so now you have two different layers here, and I'll show you why. I'm going to make the top layer, so the first one that appears in this table of contents here, I'm going to double-click that and make the entire thing transparent, so you can't see it at all. So transparent, and a transparent stroke. Okay, so now you can't see that at all. But we can see all these points. And I want to make that into something a little bit brighter and a little bit smaller. So I'm going to make that a bright pink, because why not? That'll contrast well against yellow. And go ahead and say okay. And I also wanted that smaller. So you see how much overlap we have with these. That's just going to be a pain. So I'm going to make that down to 1.4, and that looks pretty good. So now we can scroll in and look at some of these points without too much overlap. Zoom out just a little bit here, and now you'll see why we have this top layer. So right-click, open the attribute table of that layer, and sort by time. So you should see IDs 1, 2, 3, 4, 5 going down this way, and you can sort by ID too. ID and time are in the same order. Now, see how I'm highlighting 1 here. If I click and hold, drag down, I manually select. So that was the first position, second, third, fourth, fifth. All those together, I can see she moved from here to here. So this is the point where I've got to talk to you about pattern recognition in point data. There are statistical methods that I'll teach you later to formally assess patterns in point data. But in your day-to-day life, the simple recognition of a pattern and the seeking of an explanation for that pattern is going to answer a lot of questions for you or help you ask the right questions. Once you're asking those right questions, then you assess them with statistics and do comparative studies and all those good research things that good scientists do. But for the practitioner and for the person seeking to understand what's going on in the landscape, if you see a pattern, that's the beginning. This is the classic example of that. This is John Snow's cholera map for Soho in England in 1854. These few blocks of London were suffering from an outbreak of cholera. At the time, they didn't understand the cause. Every one of these black lines represents a person who died of cholera at each address. So for this one, 1, 2, 3, 4, 5 people died of cholera. There was a theory at the time that cholera was spread through the air. Come to find out, there was one contaminated pump dead center in this cluster of points. So London in 1854 did not have running water, it was all being brought from a pump. So all of these people were drinking from the same source. Modern methods of statistical analysis put the center of all these points just about there, which is visually obvious. So the obvious pattern in all this data, in all these points, allowed researchers to ask the right question about that well, which led to the understanding of how cholera was being transmitted and how it could be prevented by boiling water. Now moving back to our deer situation, let's see how she moves along. So she has moved to this cluster here and appears to be bouncing around within it, but also taking a trip over here to this other cluster. Let's look and see what we have here. This looks like it's centered around a house. She's crossing the street a few times here. This seems more dispersed, but it doesn't look like she's going daily from here to here and back. So here's some more points. And if you want to know what day it is, so we have 2013-03, March 22, at 1200, 1500, 1800, and 2100 hours. So we have a GPS point every 3 hours, except for those points where the GPS couldn't get a lock and there's no point. So it looks like this day she's moved back over to this area. So two distinct clusters. Now she's over there, moving back a little bit. It's taken a little trip out to here. Now we can ask the question, are these all at the same time? And we can use our Identify Features tool. Click, hold, drag, release a box around those three. So we have Deer 19, ID 47, 2013, 03, 24, and then 53, 78, 95, and 133. So we can open these up and say this March 25th. That one was March 24th. This one, March 28th. This one, March 30th. So you see as I open each one, we've got 1, 2, 3, 4, 5, 6 points selected here. And they're all here in the Identify Features window. And I can expand them as I want to see them. So there's another one here. That's into April 20th. So the question is, what is she doing here? What attracts her to this spot in a couple of different days throughout the spring? So there's a question for you. Why is she here? What is she doing? What feature of the landscape is she using? And is that something that can be improved? Or if we don't want her there, is that something that could be removed? There's a spot on a highway in British Columbia which has a natural salt lick, and that had to be fenced off because deer and other animals were coming to lick that and then getting hit by cars. Zooming back out here, let's go back to our attribute table. So right-click, open attribute table. And I'm going to show you why we have two layers going on here. So good to explain that. Right-click, open attribute table, sort by time. Remember, we got to do that. If we do that, you see that's been selected under there, but when you're zoomed all the way out, it hides under other features. So by having this see-through invisible layer on top that we're selecting from, we're able to always have the selected points appear on top of the other points to provide context to where she's been throughout the year, but we can clearly see the ones we've selected. So back to our clear, transparent, or invisible layer here. Open the attribute table, so right-click, open attribute table, and where were we? Somewhere down here, I think. So we're moving along. She's taken this trip out to points unknown, back to this cluster, bumping along, bumping along, bumping along. Doing all right. Just hanging out. Must have something to eat there. So she's spending days in this area. Keeps bouncing around, bouncing around, bouncing around. But there, you see we've selected all these, but I only see 3, so what's going on? She's moved. So I'm going to zoom in on that complete area there. And now we can ask the question, when did she move? So she's there, 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 there. Started moving there. So, on the 18th of April, at 1200 hours, she's going for a walk. And at 900 hours, she is still in this cluster here. So between here and here, she decided to take a walk in mid-April. And by that afternoon, she has crossed the river and landed in this other cluster here. And from there, it looks like she's hanging out there, bouncing around in that small cluster there. Looks like she's hanging out in somebody's yard, maybe browsing on their shrubs. And then we're still moving around. Oh, we've gone off screen again. Where has she gone? Alright, so now she's over to here. And what is she doing now? So there's 251, she's off screen again. And she is going on walkabout. Let's see where she's going. Back the way she came. Changed her mind. Back to there, back to the river, and has crossed the river again. 257, back to right where she was before. So she decided not to go too far on her walkabout. So that's interesting. We can see there's a clearly defined route here. She's going from point A to point B. And this, of course, is her wintering area, and her summering area is over here. or at least the area where she summered for the year for which we have data. But what's interesting here is it looks like she started on that route and then turned back. So let's see, how far along was she here? So she was all the way out to here. Looks like she was going in that direction and then turned back around, went back to whatever she was doing in this cluster. That was on the 18th. Now we're into the 20th. Let's see how long she stays here. Still there on the 22nd, but it looks like she's crossed the river again. So on the 22nd, so 4 days after she left here, she's crossed the river again. Moving in that direction. Staying in that area there. Moving and moving again in this direction. So on the 23rd, 5 days after the first movement in this direction, we have another one. So here's 282, she's hanging out in this area. So that's an interesting thing. Looks like she's just spent the night there, so maybe she bedded down in that location. And it looks like she might have done that a couple of times, so that might be a spot where coming and going, it's used. Let's investigate that with our Identify Features tool. So we have point 282. So 282 through 286, that's a contiguous bit of time there. So it looks like she just spent the night. So let's see, she left that area. Oh, 900, sure. So that I would buy that as a waking up in the morning, grabbing a bite to eat, and off she goes. And then 1717 through 1726. Let's see, so she arrives 2100 hours. And 1727 departs, looks like 300 hours. Curious. So I'm curious to look at records 1727 and 1728 to see what's going on with her then. So I'm going to right-click, open attribute table, zoom all the way down to 1727. So here's 1727. And I'm going to click off there so we can see. Go back to our attribute table here. And 1728, she's moved down here at 6 o'clock in the morning. And then 9 o'clock, 900. And then has moved by noon, 1731. Where is she going? Oh, she went a long way there. But we were back here at around 624, I think. So let's move that back where we were. Were we 624? No, we were well before that. So we were on April 25th, I think. There we are. So moving along, moving along. Looks like she's spending a night there. 9 o'clock in the morning, and she's moving again by noon. Moving a little bit, and then moving a lot of bit. There's 298, 99. Looks like we might be spending a night there. Up in the morning, and off we go. And there, I hope she had her passport, because that is the border between Maine and Quebec. So I want you to explore this data set. See what you can find out about where she's spending her time, how she's spending her time. It looks like she is spending some time within the boundaries of that cut there. That looks not terribly recent, but somewhat recent, and there could be browse within that. Looks like a structure here that she's not spending any time around at all. So this is much of the summer range here, but you can use the attribute table and the Identify Features tool to find out when she was in that particular location. Here we have another recent cut that looks like she's making some use of, bouncing back and forth here and here. So it'd be interesting to know, is she spending the nighttime here and the daytime here? Is it split randomly? Is it something she's using here in this season and there in another season? Is she going from here to here? We have a bunch of data on this one deer. That's not enough to do any valid scientific research in terms of Gini or G clustering or any serious statistical analysis. But what it can do is act as an observation, where you observe this behavior and then formulate a research question, a hypothesis, and a means of testing that hypothesis. So I want you to observe. Look at this data set, look for patterns within it, look for seasonal patterns, look for patterns within a day, patterns within a couple of days. There's a ton of interesting stuff in this data set, so spend some time with it, and I want you to look and see what you can find, what patterns emerge, what hypotheses you can come up with about the way this deer is acting. Just remember that this has got to be in order, so every one of these should be sequential, 300, 301, 302, and these are GPS fixes in theory every 3 hours, but sometimes you'll have one that misses. And this is a female deer estimated to be 9 or 10 years old on the condition of her teeth. With these data courtesy of Dr. Hansen at UMaine Fort Kent.